In this video, we're going to look at some of the plot options that are available for Contour Plot 3D, Plot 3D, and Parametric Plot 3D. The code on your screen, maybe you should, if you haven't already done so, type this code in exactly as we see it here. This was the code from the medium difficulty curve of intersection problem. You can see that we have uh, an implicit surface, in this case a cylinder. We have an explicit surface in the form of a plane. We found the curve of intersection as a plot 3D, and we put all those plots together with the show command, and we created the 4 plots together with the graphics 3D kind of option. So there's 2 plots together and then 2 plots together. The point of this video is we can see that the default for Mathematica is to plot all the surfaces in this kind of nice orange color, and the curves looks like they are plotting them in this blue color. Each of these we can change if you do not like the orange or the blue. And one reason you may want to change options is because notice in this case that we have these 3 plots, and it's kind of, because the cylinder is getting in the way, it's maybe hard to see the plane that is behind this cylinder. I mean, you can see it if you rotate it, but it'd be nice, or there may be a case where we want to be able to visualize the cylinder right through the plane. So our first plotting option is going to be to figure out how to change the opacity of the cylinder to make it more transparent. So you would just, after you've done the basic plotting command, here's your function, and here is the region on which you want to try to find all the points which satisfy that equation. So after you do the basic plotting command, you are allowed to put in the plot options. You can put plot options here, okay? And the plot options, in this case it's a contour plot, so you would want to change the style of the contours by saying contour style, okay? And you can see here that the computer is actually pretty nice to you. You type contour style, which it completed, puts the arrow, and it's giving you some options to choose from. So here we'll just say, for example, pick the opacity and hit the option that they gave you and hit shift return. And now you can see that we can see through that cylinder a little bit. We can now see the plane behind it. If you want to make the plane more opaque, less opaque, more transparent, you put the lower number here, and now you can see through that cylinder. You can see through that cylinder all the way, okay? Let's see what some other options we have. If you put contour style and you put this in curly braces, which means that we're going to make more than one option, you could do something like, you could change that surface to purple if you wanted. Right? So now the plane is purple. You can pick your favorite color if you want. You could say red, blue, whatever color that you would like. Gray. Okay, so there's a gray cylinder. Okay. Let's see if this works. Mesh. Let's say mesh goes to none. Okay. So notice that the grid, if you don't want to see that surface, that grid anymore, just say mesh goes to none, and now you can see through the cylinder quite a bit better. And let's make it a little less opaque. And so now our cylinder is gray, but it doesn't have the grid, but you can just kind of make out the surface now. Let's see what some of the other options are. On plot 3D, you can change the plot style by doing plot style. Okay, and here you need to do a directive. This is just syntax. Let's change this to blue. So you can change the surface to blue. Okay. You could change it to red or purple or orange. And let's put inside of here, you can say opacity 0.5. So let's make it a little bit more transparent. And there you go. Now you've got a plane that we can see through that plane a little bit also. Okay. And let's see. Let's go to the final. If you want this plane plot to stand out, let's send it back to orange. Okay. So there we go. Now let's change the plot style of the curve. Okay. You can also, let's say that the plot 3D, you can say mesh goes to none here also. And now it's just a plane that has no meshing on it. Okay. So let's then move to the, let me show you this so I can stay in one place long enough for you to copy down and maybe play around with each of these options. Okay. So we'd like to move now on to the curve plot, the plot options here. And it's very similar. Mathematica has nice uniformity in how they do things. You change the plot style on a plane. You can change the plot style on a parametric plot or a curve. Okay, and you say directive. If I can spell that right, directive. Why you need this is just if you want to give multiple options in the same command, you need the directive. So let's change this to black. Let's change the thickness to 0.05. You can play around with this number to see how thick it is. Okay. And now we've changed the color to black, and now the line is certainly quite a bit thicker. Just play around with this number till you get the thickness 0.03. Change, and now it's not quite so thick. Okay. So those are the plotting options that I think are the most useful to take away the mesh if you don't want to have the mesh. If you want to put the mesh back in, take out the mesh goes to none option, and now the plane should be meshed. Okay, and you can change the opacity and change the color as you see fit. And you can change the thickness of your curves. So this will be critical, when we start to get more plots together, and you'd want to be able to identify which surfaces are which. Okay. I think that's about all. Let me just kind of point you in the direction if you want to play around more. Where do you learn about these different plot options? If the computer will prompt you for some of them and you can just choose, but if you want more help, go to the Wolfram documentation. And then let me see, there has to be something in here about visualization and graphics. This is all of your plotting, and we're doing function visualization. And here you can see contour plot 3D. Just click on that, and I like to kind of go to the bottom, and then you can get all sorts of ideas about what is possible with Mathematica. Like you can change the light reflection on it. That's what this specularity is, like what color the light that's reflecting. And if you want to, I find that good for final production, but when you're playing around, any sort of options you add makes it take a little bit longer to compute. And if you want to see some more options, here are the things that are available to you. Mesh style, for example. You can draw grid lines on there, and you have examples of what is possible. So that's a good place to go, the Wolfram documentation, and go search under the different plotting commands. I think it's always kind of fun to see what they kind of think are neat examples, just to kind of see what's possible. And there you go. You could just copy and paste this and start changing different things around. So they got mesh style none, they got the specularity, the little light reflections. and the different sides face form means that on one side they're doing orange and on the other side of the surface they're doing red. So that's the kind of things that are now available to you when you move away from your calculator and start using Mathematica. So that's what you can do. If you want to not go through the help document, you can just say question mark and say contour plot 3D, for example, hit shift return, and it should bring up, hit this little thing, it'll bring up the window directly. So if you know the name of the command that you were trying to play around with, you can just type question mark in that name, hit shift return, and it should show you the help page for it. Right, so that's probably it for the basics of Mathematica. Really, we're not going to be doing too much except contour plots, plot 3D, plotting curves, and then just being able to change the plotting options. So the difficulty for you is to realize when you look at a function, do you know which plotting command to use? Do you recognize an implicit plot? Do you recognize an explicit plot? Do you recognize the equation that is a curve in 2D or 3D? In this case, that's a plot of a 3D parametric plot, so a vector valued function in one variable. Here is an explicit function in 2 variables, and here is an implicit function in 3 variables. So that is the end of this video, and we will let me show you the code one more time, which generated all these pictures, and it'd be a good idea just to, you can't go wrong, just play around with it and see what you can learn, and if you find anything cool that you want to share with us, let us know what you're looking at, and maybe we can learn some Mathematica along the way. All right, have a good day.